Hi everyone. Just wanted to go over what's going to be on tomorrow, or if you're in the A-Day class, what's going to be on Monday's test. Again, it's a straightforward multiple choice test. There's no FRQ, and I was going through this a couple of minutes ago, and I don't really have too much to add to this study guide that I posted, but I'll kind of go through it and try to be brief here, try to be respectful of your time. One, identify the type of bonding, covalent ionic, polar versus non-polar. All right, really what you're taking a look at is you'll have printed out for yourself an electronegativity table. They're very easy to find on a Google search, and have that available, and then take a look at the differences in electronegativity. Remember that 1.66 rule, that if it's greater than 1.66 difference between the two atoms, then you're looking at an ionic bond. If not, you have a covalent bond. And as far as polarity goes, any difference in electronegativity makes it polar. I'm not concerned about whether it's slightly polar. I'm not concerned, like in carbon and hydrogen, that it acts non-polar in the human body because it's a water environment. As far as I'm concerned, chemically speaking, there is a slight dipole moment, so that makes it polar. And the only elements that have the same exact electronegativity values are the non-polar bonds. List and describe factors that influence electronegativity and describe periodic trends for ionization energy, electronegativity, electron affinity. Again, as you go from left to right, electronegativity and electron affinity increase. Ionization energy increases, and that's because the effective force increases. You have more pull, more effective pull coming from the nucleus. You're not increasing energy levels. As you go from left to right, you're only increasing the number of protons. And electronegativity, ionization energy, and electron affinity decrease as you go down the periodic table because of increase in quantum energy. The outermost electron is far away from the nucleus. The more energy levels you have, the more energy the outer electron has, the more likely it is to be removed during bonding. Number 3, differentiate among the mechanisms, properties of ionic covalent. And again, that was in my slideshow, directly from the slides. What is the step-by-step process? What are the properties? Look in terms of energy from melting points, that sort of thing that I really like. And the big thing with metallic bonds, of course, in the mechanism is that it creates that delocalized electron that can move around, and explains the properties of metallic bonds. For number 4, they're looking for in a polyatomic ion that you understand two things. One, that one of the bonds is going to be a coordination or dative bond. The unshared electron pair of one atom combines with empty orbital space of another atom, and that creates hyperconjugation. It creates a charge problem that's spread out throughout the polyatomic ion, and then the ion uses that charge to bond to something else. Differentiate among atomic radii, ionic, covalent, and van der Waal. Atomic and ionic is when the atom is by itself. Covalent is intra-nuclear distance divided by 2 in a covalent bond. And van der Waal is the distance between molecules. So that depends upon whether the molecule is solid, liquid, or gas. And you're looking at the distance between nuclei between molecules divided by 2. Number 6, differentiate among dispersion, dipole-dipole, hydrogen bonding. Those are all called intermolecular or van der Waal forces. I would know the energy differences, that hydrogen bonding is the highest energy and dispersion is the lowest energy. Dispersion, all molecules have dispersion forces. Only polar molecules have dipole-dipole, and only polar molecules where a hydrogen is specifically bonded to a fluorine, oxygen, and nitrogen produces a special dipole-dipole called hydrogen bond. Number 7, given electronegativity values, determine, well, we already said ionic versus covalent, polar versus nonpolar, but relatively strong or weak. Again, the bond is based upon thermal energy, not water environment. So in chemistry, we're going to look at those elements on the far left bonded to those on the far right. So the greater the difference in electronegativity, the stronger the bond. And same thing with reactivity. Elements on the far left are going to combine with greater reactivity. In other words, they're going to release a lot more energy when they bond to elements on the far right. Given a table of electronegativity values, draw polarity vector arrows. Okay, so you're not going to be able to draw the arrows, but I will have some that will have them correctly drawn and incorrectly drawn on the multiple choice, and you, of course, choose the one that is correctly drawn, that the arrow goes towards the electronegative, and the positive tip of the arrow goes towards the electropositive element. And when they mean approximate percentage of ionic bond character, remember that 1.66 difference number. If it's 1.66 or greater, then you're looking at more than 50% ionic character. If it's less than 1.66, then you're looking at 50% or greater than 50% covalent character. So the greater the difference in electronegativity, the more ionic the mechanism, the more ionic mechanism is important, and the less than 1.66, the covalent mechanism is more important. And really, that's it. You should do well. I'll have the test posted on Edmodo. You can take it at 9 a.m., 2 p.m., or 6 p.m., whatever works best for you. And good luck.